What I'm going to do in this example is show how we can model components utilizing both synchronous as well as ordered methodologies. We're going to essentially create a linkage between our tie rod and our spindle, and we can do this in the context of the assembly. What you'll notice is from the assembly we can create brand new components by specifying what their name and location is relative to the other components. In this example, I'm going to call this the steering arm, and then also specify exactly where it's going to reside. In this case, I'm going to specify the center point of the tie rod. You'll notice that our components remain active or visible on the screen so that we can reference those and make sure that our new part's going to fit properly while we're doing the design. The other nice thing too is I can borrow geometry off of other components. So for example, if I know that my part needs to be similar shape or size to other components, what I can easily do is just tell Solid Edge I want to extrude from that face off of the other part. And you'll notice how Solid Edge very quickly copies that geometry for me. All I have to do is specify what its depth is. In this case, we'll give it a 1-inch thickness. I also want to split this element a little bit, and I'm just going to create some construction geometry. Very easily I can go through and specify that I want to reference the center point. I could just type C on the keyboard and that will automatically tie it to the center point of the hole. So now that we have some geometry created, I can take either one of these two regions and either add or remove additional material. And what I'm going to do is just take this portion of my part, and notice as I pull out of the part it's going to add material automatically, or if I push down into the part it'll remove it. And what we want to do is just give maybe 1/8 of an inch relief there and remove some of that material. I want to do the same thing on the opposite side. Before I do that, I'm just going to turn off those background components and just focus on my design. And what I want to do is, you'll see on the opposite side we haven't created that cut yet, but before I do that I just want to create a reference plane. Have you ever created reference planes in an ordered mode inside of Solid Edge? In creating those planes at angles or parallel to different faces, it takes quite a bit of work, maybe more work than that's necessary. With Solid Edge, when you're working in synchronous, I can easily touch the face of the part and it creates a coincident plane, but notice how the steering wheel automatically pops up. So basically, if I wanted to create an angle, I can go ahead and do that, or if I wanted to change the angle or the way that the angle is being modified, I can also come through here very easily and change the orientation of the steering wheel and maybe create an angled plane in this orientation. What I want to do is just create the plane at a specific distance from that top face. So in this case, I'm just going to pull that down a 1/2 inch. That's essentially going to be my mirror plane. And what I'm going to do is just tell Solid Edge that I want to mirror that cutout to the opposite side, utilizing that plane that we just created. So as we rotate that around, you'll see that we now have that cut out. Again, replicating geometry in synchronous is a very easy thing to do. So again, I can just window select around what I have, and I essentially want to take that geometry and just copy it. I can hold down the control key on my keyboard, specify the direction in which I want to copy, and I just want to copy that out 8 inches. I also want those two to face each other, so what I'm going to do is I'm just going to place my steering wheel at the center of the hole and then just tell Solid Edge to rotate that around 180 degrees. So I've got the basis of my components. I've got the two ends of this linkage or this steering arm that we're generating. Now what I'm going to do is go into an ordered mode. So as we transition to ordered, I now want to create the center portion of our body. And I can do that very easily with different tools. So as I right click and go to my radial menu, you'll notice I have an option here where I can grab commonly used features. So for example, if I want to customize this radial menu and utilize specific tools, maybe these are tools that I use over and over again, I can customize this menu. And in this case, I'm just going to grab a lofted protrusion. From here, we'll specify that we want to loft material between this face here and then the opposite side. Before I finish out that particular operation, I also want to tell Solid Edge that I always want them to come out tangent from those two locations. So we'll change those two to tangent continuous and complete that step. And that gives us the middle portion of our body. And you'll see why that tangent continuous comes into play a little bit later, why that's important. We'll go ahead and round some edges. So we'll go ahead and change this to all fillets and we'll take all those internal fillets and we'll round those to a 1-inch value. And then we'll change it to face, and what we'll do is we'll grab the back face of this part as well as this front face and change that to 1/8 of an inch. So what I'm going to do is I'm going to turn on those background components just so we can kind of see where we are currently. We can see we've kind of got the part started, but it's not really right now even remotely close to where it needs to be, but that's okay. What I'm going to do is, we know that obviously that this end of our part needs to be at an angle. It probably needs to be adjusted a little bit. What's nice about synchronous technology is I can come here, I can grab different faces of the model and just very simply pull them up. So I'm going to come up just some random or arbitrary distance here. I also know that maybe these need to be pulled out a little bit. You'll notice how those ordered features automatically update with the changes that we're making. So that tangent continuous feature with our lofted feature that we've generated earlier, it's staying tangent. And then the last thing that I might want to do is I might want to rotate this end of the part. So we'll go ahead and snap this to the center of our hole. Get our steering wheel in the proper orientation. I'm going to rotate this up just a little bit. So we'll snap it to the center. And then I might just want to rotate that end, let's say 15 degrees. I'm gonna close back out to the top level. We've modified the part geometry itself, but now we want to rotate it around and get it closer to its position. So what I'm going to do is just simply pick on the entire part, and again place our steering wheel exactly where we want it. We'll place it right there at the center, and then just rotate this around closer to where it needs to be. Still got a little bit of work to do, as we can see that it's not quite exactly where we need it to be. So what I'll do is I'll go back into the model just by double clicking on it, and we can do some additional edits to get it where we want. You'll notice also over here on the left hand side we've got both synchronous features as well as ordered features. I'm going to kick back over into the synchronous area of our part, and what you'll also notice is we can very easily create relationships between components. And what I mean by that is right now I need the end of my part to snap up to the end of the spindle here, and we could do that with what we call face relationships. So as I grab the end of our part here, I can go ahead and tell Solid Edge that we want to make elements coplanar. So I'm going to grab the top face and say make that face coplanar with the bottom face of our spindle, and Solid Edge will automatically snap that up into position. Same thing, I also want the holes to be lined up, so I can also grab a concentric relationship and tell Solid Edge to take the cylinders of these two parts and snap them together. What's nice about that is, you'll see here in just a second, is the ordered features again will automatically update. While I'm here in the synchronous mode, I'm going to go ahead and place a dimension on our part, just specifying what the thickness is on this end, and right now you can see it's 1 1/4 inch. So let's go back over, we'll go back into the ordered mode or environment, and you can see that our tangent continuous area has updated quite nicely there. If we want to make some additional changes, we can go through, I can grab the dimension that I just placed, and we have a nice tool now where we can change dimensions symmetrically even if they're not symmetric about the base reference planes. So as I click on the dimension, you'll notice it changes on both sides for us. Maybe we want that to be 1.5 inches. Maybe after doing some studies, we also maybe need this end of the part to be a little bit thicker. So again, I can grab a couple of faces here, and we can very easily move those faces up, maybe 1/4 inch. We can type that value in and have a precise value, or I can just grab the dimension itself and say, well, we want to go ahead and make that 1.5 inches. And again, just by changing the dimension, it's going to automatically update that part. So again, you'll see that we've very easily, utilizing both synchronous features as well as ordered features, created our model, very fast and flexible edits to get it to be exactly the way that we wanted it to be. So that concludes this demonstration.